There's a motor sitting inside a car right now that most people have never heard of, and the companies that have heard of it are quietly panicking, not because it's faster, not because it's flashier, but because of what it reveals about how the entire electric vehicle industry has been thinking about energy and why that thinking might already be obsolete. This is the story of how a company that started making batteries for cheap mobile phones ended up building the technology that may be the single biggest threat the auto industry has ever faced. And the strangest part, the warning signs were there the whole time. Nobody just took them seriously enough. But before we get to the motor itself, there's something you need to understand first. Because if you skip the origin, you'll miss the thing that makes this whole story make sense. It's 1995, Shenzhen, China. A man named Wang Chuanfu starts a company with around 20 employees and a very simple mission: make rechargeable batteries. Not car batteries, not power station batteries, the kind that go inside a Nokia phone. That's it. That's the whole vision. Nobody was threatened. Nobody was watching. It was a battery company in a city most of the world hadn't heard of yet. But here's what was actually happening inside that company. Quietly, every single day, they were learning something that car manufacturers, companies with 100 years of engineering history, never had to think about deeply. They were learning how energy moves, how it stores, how it wastes, how it dies, and most importantly, how to stop it from dying too soon. For 8 years, BYD just made batteries and got very, very good at it. Then in 2003, Wang Chuanfu made a decision that the entire auto industry found almost funny. He announced BYD was going to make cars. The reaction was exactly what you'd expect. Established automakers didn't lose sleep over it. Analysts called it overreach. A battery company making cars was like a candle maker announcing they were entering the electricity business. Technically related, practically absurd. Except that's almost exactly what happened with electricity. And the candle makers lost. BYD spent years doing what everyone expected them to do, making affordable, unremarkable petrol and diesel cars, learning the industry, understanding manufacturing at scale, and watching. They watched oil prices climb. They watched pollution choking Chinese cities. They watched a young American company called Tesla start selling electric cars to wealthy early adopters and getting called visionaries for it. And then BYD made their move, not with a flashy reveal, not with a celebrity CEO on stage. They simply started applying 30 years of knowing how energy works to the one problem that was killing EV adoption everywhere in the world. Range anxiety, the fear that the battery dies before you get where you're going. But here's where the story starts to get uncomfortable, because what BYD figured out wasn't just a battery solution. It was something buried deeper in the system inside the motor itself. And that discovery is the reason you're hearing this story today. Most electric motors in production vehicles right now operate on systems between 400 and 800 volts. That range became the industry standard because it worked. It was safe, scalable, and good enough. Good enough. Good enough. BYD looked at that standard and asked a different question. Not, how do we work within this range better, but what happens if we leave it behind entirely? The answer they landed on was 1000 volts, and on paper, that might sound like a modest upgrade, just a number going up. But the physics of what changes at that threshold is where the real story lives. Think of electricity moving through a motor the way water moves through a pipe. A narrow pipe can carry the same water as a wide pipe, but it has to push harder, build more pressure, generate more friction, and lose more energy to heat along the way. Now imagine widening the pipe dramatically. Suddenly the same amount of water moves faster, smoother, and with far less waste. That's what 1000 volts does. The energy moves faster through the system. Less heat builds up, less power is lost before it reaches the wheels. The motor works less hard to deliver more output. And because the motor is working less hard, it lasts longer. One number for simultaneous improvements: range, efficiency, power, delivery, and longevity, all moving in the right direction at once. But that's still only half the story, because the voltage is what the industry will talk about. The part they won't talk about as much, the part that actually makes this harder to copy, is what's happening inside the motor physically. BYD changed the materials. The magnets inside a conventional motor do what magnets have always done: create a field that drives rotation. They work. but BYD replaced standard magnets with a high-performance, rare earth variant that produces a stronger field with less material, more output, less weight, less energy lost to resistance. Then they changed the steel. Normal motors use steel sheets inside the core to conduct the magnetic field. Thicker sheets are cheaper and easier to work with, but thicker sheets also mean more energy is lost to something called eddy currents, tiny loops of electricity that form and dissipate as heat, serving no purpose except waste. BYD switched to ultra-thin steel sheets. The eddy current losses dropped significantly. The motor runs cooler, the efficiency climbs again, and then they built a cooling system directly into the motor architecture, not bolted on as an afterthought, but designed in from the beginning. Heat is removed continuously, even under sustained high-speed driving. The performance curve that normally drops after the first 20 minutes of hard driving, it flattens out. Better magnets, thinner steel, integrated cooling. None of these innovations are individually earth-shattering. Competitors could look at each one and say, we could do that. What they cannot easily do is build all three into a single motor. Then pair that motor with a battery they also designed themselves. Inside a vehicle they manufacture end-to-end without relying on a single outside supplier for the critical components. That's the wall, not the technology, the integration dot. And this is where the Blade battery enters the story, because this is where the threat becomes real. BYD's Blade battery was already considered one of the safest lithium battery designs in the world. Before this motor existed, its slim, elongated cell structure distributes heat differently than conventional packs, making thermal runaway the dangerous chain reaction that causes EV fires significantly harder to trigger. But safety was never the point of pairing it with the new motor. The point was what happens to range when you connect a battery engineered for efficiency to a motor engineered for efficiency, both running on a 1000-volt system that wastes less energy than anything else currently in production. The answer is that vehicles which previously delivered 400 to 500 kilometers on a single charge are now delivering 600 to 700, not in laboratory conditions, in real driving. And the high voltage system means charging is faster too, because more energy can move into the battery in less time before heat becomes a limiting factor. For years, the three criticisms of electric vehicles were always the same: range is too short, charging takes too long, and who knows how long the motor and battery will actually last. BYD's new system addresses all three simultaneously, and they're doing it at a price point that makes Tesla's entry-level vehicles look expensive. That is not a minor product update, that is a structural shift. Now zoom out, because what's happening in one company's engineering department is about to become a geopolitical and economic story that touches every major car market on Earth. In the United States, Tesla has operated with a kind of comfortable dominance. The brand, the supercharger network, the software ecosystem, these were moats that made the price premium feel justified. American consumers bought into the idea that the best EV was the expensive EV. BYD, entering that market with longer range, lower price, and the same or better real-world performance, doesn't just compete with Tesla, it challenges the assumption that premium and advanced are the same thing. Once that assumption breaks, the pricing pressure doesn't just hurt Tesla, it reshapes what every American consumer thinks a fair price for an EV actually is. In Europe, the story is different, but the stakes are higher. European governments have committed to aggressive timelines for banning internal combustion vehicles. The challenge was always the same: who builds the affordable EV that regular families can actually buy? Not the €80,000 showcase vehicle, the practical, reliable, long-range car for the person who drives 50 kilometers to work every day and can't afford to gamble on range anxiety. BYD is answering that question in a way no European manufacturer has managed to yet. And when the affordable option is also the most efficient option, the timeline for ICE bans doesn't just stay on schedule, it accelerates. In India, in Southeast Asia, in markets where price sensitivity is everything and infrastructure is still developing, BYD's combination of low cost, long range, and hybrid flexibility creates something that hasn't existed before. An EV that works even where the charging network is sparse, because the hybrid version can bridge the gap. The global auto industry spent decades assuming that the path to EV dominance ran through California or Stuttgart or Tokyo. It may have been running through Shenzhen the entire time. Here's the part that doesn't Get said loudly enough. Toyota perfected the hybrid. Tesla perfected the software-defined car.